forces are due to interaction. You know that a push or pull on an object is called force. Now let us see some situations where we apply force. Mr. Brown is standing behind a stationary car. The car does not move if he does not apply any force. Now, he pushes the car, which means he applies the force on it, and the car begins to move in the direction of the applied force. This suggests that a person has to push the car to make it move. Let's see the situations where the two girls are applying force on each other. In the first case, both the girls are pushing each other, whereas, in the second case, both the girls are pulling each other. Also, observe this situation, in which a man tries to pull a cow, and, in turn, the cow oppose the force. Thus, both the cow and the man try to pull each other by applying force in opposite direction. From all these examples, we understand that at least two objects must interact for a force to come into play. In other words, forces are due to interaction. Let us try to learn more about forces. Sam is trying hard to push a heavy box, but he finds it very difficult. Then, he asks his friend, Peter, to help him. When both of them push the box in the same direction, it is much easier. But, when Sam and Peter try to push the box at the same time, in opposite directions, the box moves towards Sam. This indicates that Peter is applying more force than Sam. Similarly, in the game of tug-of-war, when two teams try to pull the rope in opposite directions, the team applying more force wins the game. Thus, we have studied about the nature of forces, that forces applied on an object in the same direction add to one another. But, if the two forces act in the opposite directions on an object, the net force acting on it is the difference between the two forces. So, we learnt that a force could be larger or smaller than the other, and the strength of a force is usually expressed by its magnitude. Also, we must mention the direction in which a force acts. If the direction, or the magnitude, of the applied force changes, its effect also changes. The net force on an object is zero, if the two forces acting on it in opposite directions are equal, as in the game of tug-of-war, when the rope does not move. Note that, if the force applied on the object is in the direction of its motion, the speed of the object increases. For example, the speed of the tire increases whenever it is pushed. Many a times, application of force does not result in a change of state of motion. For example, no effect of force is observed when you try to push a wall.